Hi everybody, welcome back. Today we're going to take a look at the Masterchannel tech stack and how we manage to master more than 60,000 tracks every month. My name is Simon, one of the main developers, and I'm going to walk you through the whole setup as a user. And as always, if you have any questions, please pop them in the comments below and we'll do our best to answer them. But let's dive right into it. So if you are a user and you use Masterchannel, the first thing you obviously do is you go to our website in your browser, either on your phone or on your desktop. And what actually happens is that you communicate with our front-end server. And the responsibility of our front-end server is, you could say, purely visual. So everything that the front-end server does is return layout elements, visual elements to your browser so that you can interact with the website. So the color of buttons, where the buttons are placed, different overlays that we have or animations that we have on the website. All that stuff is the responsibility of the front-end server. So what happens when you, for example, upload a file? The front-end server has no understanding of an audio file or of mastering in general. It only reacts to user input and the state of the whole system, which we're going to get to in a bit. But the moment you upload a file, the front-end server, first of all, returns to you an updated visual element, which in our case is the loading animation or the uploading animation that indicates to you, okay, I'm now uploading my file. But behind the scenes, the front-end server actually just passes on that file to our backend server. And our backend server is kind of the opposite of the front-end server. It has no graphical user interface and it doesn't serve any visual elements. It can only be communicated with through an API. But on the flip side, it has all the logic that we need to run the service. It understands what an audio file is, what criteria are required for mastering. It understands how to start a mastering process. It understands the different states of the mastering process, and so on and so forth. So the moment you upload an audio file to the front-end server, the front-end actually passes on that file to the backend server. Let's call that upload file as well. And now the backend server, because it understands audio files, it checks if that's actually a valid audio file and if it can be mastered. And then, once it knows what the status of the file is, it reports that back to the front end. So let's say file status here. And if, for example, the file you uploaded contains only silence because it was bounced wrongly from your DAW, or it's in a file format that we can't process, the backend server tells that to the front end through a status code, and then the front end knows this was not a valid file. I need to display a visual element to the user that tells the user that this was not a valid file. And that's why you then see the overlay, which tells you that this is not a valid file. If it is a valid file, what actually happens in the backend server before it reports back to the front end that it is a valid file, it stores the file in our central cloud storage so that we can later process it. So we're kind of uploading the file for the third time here to our cloud storage because we need to access it later from a different part of the system, which we're going to get to. And then also, because we've performed some analysis on the track, we know it's an audio file, it has certain properties. We also store that information in our database, store file metadata. So now the backend server has told the front end that this is a valid file. We can proceed with whatever we want. Now the front-end server actually, on your behalf of the user, because it knows you uploaded a file with the purpose of mastering, it initiates a master request. So it tells the backend, I want to master that file. So that's a master request. And now the backend just double checks, okay, does this file still exist? Is it a valid file based on what we've stored in the database, which in our case it obviously is because we just uploaded that file. It then can communicate back to the front end whether or not it can confirm that the request was successful. In order for the request to be successful, the backend server actually only does one thing. It adds the file or the master request to our master job queue. And the master job queue is essentially just a to-do list for our audio engine of all the files it has to master. So that if the audio engine goes offline for some reason, or we have other infrastructure problems, we always know where we left off and we know which files have been processed and which files have not been processed. And also that queue allows us to manage varying traffic from different users. So for example, if we have one user that uploads 200 files and we have one user that just uploads one file, It wouldn't be smart to upscale the whole system to cater to that user with 200 files, and the user that only uploads one file would have to wait until the 100 other files are processed, right? That's why I have a queue system that intelligently schedules jobs and says, now we can go to a different user and master their file first based on the current server capacity that we have available. So now the backend has confirmed to the front end that the master request was successful. It's been added to the queue. What the backend server also does in that response is that it tells the front end how long it thinks the mastering is going to take. So it looks at historically the last, I don't know, 100, 200 jobs. It looks at different properties of the file, how big of a file it is, if it's a spatial file, if it's high resolution, those type of aspects. And based on that, it returns a time estimate back to the front end and says, I suspect this takes, let's say, 2 minutes. And then the front end server knows, okay, for the next 2 minutes, this file is being mastered. And there's no point of me asking during those 2 minutes what the status of the file is, because I just assume that the backend is very good at guessing how long it's going to take. So the front end server actually goes silent in communicating with the backend server. And that's when you, as a user, see the animation that displays what's being done to the file. And on the other end of the system, we have our audio engine. And our audio engine contains all of our artificial intelligence stuff. It renders all the different versions we need of a file. We need the raw master file, obviously, but then we also need previews for the browser. We need different metrics that we show in the analysis section of the player component. And the audio engine essentially just looks at the queue and checks, is there a job I can do? Based on the current compute capacity that I have, can I work on a new job? And if so, it fetches that job, fetch master job. And then obviously it needs the file to do the mastering, right? So what happens is that the audio engine, let's put it over here. The audio engine actually downloads the file from our cloud storage. It then also loads associated metadata from the database, metadata. And then it can start the mastering process, right? And let's assume the backend was very good at guessing that's going to take 2 minutes, which usually it is. Then after 2 minutes, the audio engine is done. It has done all the mastering. It has rendered all the different files. What it then does is it uploads the master results to the cloud storage again. Upload master results. And it also logs all the master information in the database. So now the whole job is pretty much done, right? So the mastered file is in the cloud storage. The information about the mastered file is in the database. Now we actually just need to communicate that back to the user. And as I said, the front end actually went silent for a while because it trusts the backend with its estimate. And after that time has passed, it's gonna ask the backend again and request a status update, because it wants to know what's going on. You know, is the file done? Do you need more time? What's the status? And let's assume everything went according to plan. The file was done in time, and it's available in cloud storage, and all the information is in the database. Then the backend server will just return all the information from the database. Return master status. So what it actually does is fetch master info, fetches that from the database, and then returns it to the front end. And now what the front end can do is it can actually make you as a user download all the assets that you need to play back the previews in the browser, or to later download the file from the cloud storage. So what then happens is that you as a user download the master results from our cloud storage. And that's essentially how the whole system works today. Now, obviously, there's a lot of stuff you can optimize here, because the system grew over time and we had different requirements, and now we have more and more traffic coming in. So one thing we want to work on is actually decoupling the backend server completely from the audio engine. Right now, they both communicate through our database, which is not ideal. Ideally, what we want to do is put all the information that's necessary for the audio engine to master a job into the items that we put into the job queue, so that the audio engine doesn't actually have to communicate with the database, and they can just upload the results to the cloud storage after the job is done. because that way we would reduce database load and we would also decouple the system a bit more, which makes it more robust towards failure and more performant, because every time you query a database, you need compute capacity and it slows down the service. Another thing we've added recently is caching. So let's say in the case that the backend said that the job would take 2 minutes, but it actually took 3 minutes. What the frontend server is going to do is it's going to start polling every 5 seconds to ask, okay, but what's the status now? What's the status now? Because obviously you as a user are waiting, right? You're impatient. You thought it was going to take 2 minutes, but now it takes 3 minutes. So the frontend server, it's very stressful and aggressive towards the backend server, asking what's the status, what's the status, what's the status. And if that happens with a lot of users simultaneously, that can really drastically impair the performance of the entire system, because it keeps querying the database. So we have a caching layer here now that remembers, it's kind of like the short-term memory of the backend, if you will. It remembers different statuses of different files, and it updates itself automatically every 10 or so seconds. And if a request comes in from the front end asking what's the status of this file, instead of the backend having to communicate all the way with the database, it can just return the information from the cache and say, I remember that the status of this file 5 seconds ago was this or that. So that's another optimization we've implemented. And then obviously something I've also skipped here is the whole security aspect. Because there's always malicious users, there's always other companies trying to crack our code of mastering, and for that purpose we obviously have firewalls in place and other mechanisms to protect user data, to protect our IP and all that good stuff. But this is a high-level overview of how Masterchannel works. I hope that gives you an idea of what happens behind the scenes whenever you upload a file to Masterchannel. And if you have any further questions, just let me know and I'll be happy to answer them. Otherwise, I'll see you next time.